Hello, and welcome to today's webinar, Getting Started on Your AI Journey with IBM Watson Studio. My name is Liz Herrera, and I am the Director of Advanced Analytics for LPA Software Solutions. Before we get started, I want to briefly introduce LPA to those folks on the line who are familiar with us. LPA Software Solutions is an analytics consulting firm that has been in business since 2001. We have over 500 clients across a variety of industries, including banking and finance, education, energy, government, healthcare, hospitality, insurance, manufacturing, and retail. We are an IBM Platinum partner specializing in data and AI. In addition to implementing and training on IBM's technology solutions, we also provide consultative services to our clients on analytics strategy, business intelligence, data management and governance, data science and AI, as well as financial analytics and performance management. Our team members have an average of over 10 years experience in the field implementing analytics solutions. I want to thank you again for joining us and move on to the content for today's webinar. We'll start with a high-level overview of data science and artificial intelligence, and then I will provide an introduction to IBM's data science platform, Watson Studio. We'll take a look at Watson Studio capabilities, and then we'll wrap things up by providing some recommendations for how you can get started on your own data science and AI journey. Let's start by talking about data science and AI. There's been a lot of hype around data science and AI recently, and it can be hard to distinguish what's real versus what are just buzzwords in marketing. We often see data science, machine learning, and AI used interchangeably, so it's worth taking a few minutes to level set and make sure we have a common understanding of these terms. Data science encompasses several processes and often requires the participation of multiple stakeholders. Starting at the bottom, we have our data scientist who meets with the business to discuss a business problem or question. She then maps that problem to the data that she can access across multiple sources. This is most often internal data, but there has been an increased focus in incorporating external data sets for some added insight. Next, she does some data cleansing and transformation to prepare the data for some exploratory analysis. And you've probably heard the statistic that 80% of the time spent on an advanced analytic effort is tied to data preparation, and that's still true. It's an iterative process of doing feature generation and understanding the structural characteristics of the data. Next comes modeling, which is the application of statistical algorithms to the staged and prepared data. There are newer algorithms to choose from, including more neural networks, decision trees, boosted models, just to name a few. The data scientist shares back results with the business through visualization and communication. This is also often iterative, where you get some feedback and refine analyses based on the additional input from stakeholders. And finally, we have deployment. This is an incredibly important part of the data science process. It determines how the data science results will be used to inform decision-making and actions that will impact the business. I would argue that this step should be considered early in the cycle. Doing research is great and often necessary, but you want to have some idea of how you would proceed with using results and managing any analytical assets that are developed. Machine learning can be found at the intersection of methodology. In this case, we're talking about data science, data mining, computer science programming, and the elements of data, features, and algorithms. Machine learning applies analytics and algorithmic methods to data in order to predict something. We can use this approach with data that has been well-defined and categorized, and that's called supervised learning, or with unlabeled data where we let the algorithms identify patterns and importance, which is what we call unsupervised learning. The most common machine learning methods used today are classification, regression, clustering, association, and dimension reduction. Finally, we have AI, artificial or augmented intelligence. There's a great quote from the renowned computer scientist Larry Tesler. He worked at Xerox, Apple, Amazon, and many other companies. And he said, artificial intelligence is whatever hasn't been done yet. But in all seriousness, there has been an exponential increase in data, as well as real advances in technology that combine capabilities like machine learning, natural language processing, and deep learning. These factors have made AI accessible to the marketplace. In its best iteration, AI is transparent and it supports human decision making. Some examples of where you may encounter AI at work today include using a smart home device to ask a question like what the weather is going to be like tomorrow, or interacting with a virtual assistant when you dial into a call center for support. Getting a call from your bank's fraud department because they detected suspicious activity on your credit card transactions is another example. Also, dynamic pricing changes for goods purchased online, or pattern and image recognition to support doctors in healthcare, or for quality control on an assembly line. And there are many more applications for AI, and I'd be willing to bet that there's an opportunity in your business space to uncover how AI could be used to provide more value. So, how can we approach AI? We've all seen the analytics maturity curve, and this new iteration of the maturity curve is the AI ladder. At the foundational level, we focus on collecting data and making it more accessible to users. Then we organize it so that it becomes a trusted source. This is the step where data governance is key. Next, we're ready to analyze data using AI methodologies. And finally, the top rung of the ladder is where we infuse AI across your business by operationalizing or deploying it in a transparent way. From a technology standpoint, there are a lot of options out there to support you as you move up the AI ladder, which is really fantastic. There's a lot of value in being able to explore both open source and proprietary technologies. The IBM Data AI portfolio provides a whole ecosystem with capabilities that include an infrastructure layer on the bottom, data science in the middle, and AI with Watson applications and solutions on top. Some of those applications are things like Watson Discovery, Watson Explorer, Watson Virtual Assistant, and a lot of other APIs. We're going to focus on the middle layer today, specifically Watson Studio. We'll also touch on Watson Machine Learning because it is the deployment engine that goes hand in hand with the Watson Studio building environment. So, what is Watson Studio? Watson Studio is an integrated data science and AI platform that combines enterprise and open source technologies. It's the best of both worlds from a capability standpoint. You have the flexibility to extend functionality with thousands of algorithms, statistical and analysis packages, and you have a scalable infrastructure that supports rapid development and deployment. There are code-based and visual interfaces for use in building out data science and AI models, so you can accommodate different users with different skill types in a single environment. A key element of the platform is its ability to facilitate collaboration. Teams of data scientists and analysts can share data assets, modeling assets, deployment assets, all within a governed and role-based space. The platform enables the management and deployment of analytical assets as well, and it's available in a variety of formats, including on-premise, cloud, or hybrid. So I want to take 1 minute to dig in a little bit deeper to the deployment component. Watson Machine Learning is the engine that allows you to manage and deploy assets, as well as to retrain models dynamically over time. Models are typically not static or a one-and-done deal. If you're using the result of a model to impact business decisions, then you would expect to see changes in your data over time. Models also naturally degrade in effectiveness over time, so having a mechanism to monitor and manage them is an important part of doing data science. Let's talk about the specific components of the Watson Studio platform. On the open source side, Jupyter Notebooks and RStudio are integrated into the single interface. And there are a variety of applications and microservices that can also be called to and executed within the environment. These include decision optimization, the ability to do content analytics with unstructured data using Watson Explorer. There's an SPSS Modeler interface for those folks familiar with SPSS called Modeler Flows, as well as capability to do data preparation and refinement, generate automated models, and layer visualizations on top of data science and AI results. I also want to point out the Auto AI functionality in Watson Studio. Auto AI automatically ingests and prepares your data and it generates new features, selects algorithms to apply to the prepared data, and then it optimizes parameters to produce a series of models. You can explore the model results as well as easily deploy them. This is a really good option if you want to do some exploratory data science in an automated fashion. IBM's Data Science and AI platform has been recognized as a leader in the market for delivering multimodal predictive analytics and machine learning. It really is unique in that it has the integrated open source and enterprise technology in concert with a model management and deployment component. Before I walk you through a demonstration of the platform, I want to discuss some of the areas where data science and AI can be applied. This is not an exhaustive list, but these are some areas where our clients have started exploring using data science and AI. So things like improving forecasting for budget and capital plannings activities, or detecting risk factors for underwriting and insurance. We've also had folks look for what they call hidden defectors in retail banking. So those individuals who are likely to let their account get dormant and then eventually close out and leave and take their business with them. Also doing some predictive maintenance on the manufacturing line, so proactively identifying issues on the production line. Also determining items at risk of decline from a consumer product standpoint, so which products should we be paying attention to, either to deprecate or potentially to infuse some marketing money into so we can boost sales. Also improving marketing reach and increasing the visitor numbers and entertainment. So how can we apply data science and AI to inform our campaign strategy? And finally, automating our interaction with customers to reduce costs, improve customer satisfaction. And for example, we're working with a call center to understand how they can leverage AI as a virtual assistant to help deflect calls, to allocate resources more effectively, and to reduce call times. Okay. So at this point, I'm going to switch over to Watson Studio. And you'll notice on the welcome page, I can create a project or search some assets. I actually have projects already set. We're going to look at one in particular, but you'll notice that I can view my roles. I can see the folks who are collaborating on my team, and then some information about when the projects were created. So it's a nice little snapshot. We're going to look at this specific example, data science and AI using Watson Studio. I can see an overview of this project. I have 7 assets associated with it. I have 3 collaborators. I'm one of those collaborators. And then I have some additional information if I need to dig down into that. I can also view those assets, and we'll spend most of our time on this particular page. So I'll come back to that in just a second. But we can also view our runtime environment, so I see how much capacity I've left. I am working on the cloud right now, so we're working in capacity unit hours. I can also view any jobs I have scheduled, assets that I have deployed. I can also manage who has access to the projects. In this particular instance, I'm the administrator, and I have some folks on my team who can edit the assets as well. So going back to the assets page, I basically imported a couple of data sets, and I'm using flat files, but you can use connected data, which I'll talk about in just a minute. But just to give you a little snapshot here, I'll click on the sales data link so that you can view just a preview of the data that I imported. So I have information about products that we've sold. I have information about the profit. I have information about the sales regions. If I wanted to, I could do some profiling. I can also track lineage of the data. If I wanted to, I could also do some data preparation in this step. So there's a refinery aspect or component to Watson Studio. And I'm going to go back for a minute here. And before we actually jump into doing some analyses with the data, I just want to point out at the top of the bar here, we can add to project. And this is really where I did add the data set. So I selected data and I imported the flat files. If I wanted to, I could create a data connection. So this could be to object storage somewhere. It could be to on-premise data. I also have some other options for analyses. And I'm going to walk you through a few of these today. As you can see, there are several. So you can spend a lot of time exploring a lot of the functionality that comes out of the box in Watson Studio. We're going to look at an auto AI experiment. So looking at automated AI modeling. We're going to look at Jupyter Notebooks, and we're going to look at modular flows. But you could also build out dashboards for your results. You can do visual recognition if you have any unstructured picture data. There's natural language classification as well for any unstructured text data. Lots of machine learning, which we use for deployment. So once we build a model, we can deploy the model. There's some deep learning algorithms. So these are neural network based. They can use that learn based on your data. There's also the capability to pull in streaming data. So it doesn't have to be static data. If you have data in motion, you can source that as well. There's also options for additional neural network models and then decision optimization if you have, say, a logistics problem that you need to address. So in this instance, as I mentioned, we have 3 different folks collaborating. I have 2 data assets, one for sales, one for customer data. And we're going to explore this data a couple different ways. So the first thing I'm going to do is actually jump down to my Jupyter Notebooks, and I'll open up my data exploration that I've already set up. And under the covers, this is using Python, but you'll notice with Jupyter Notebooks that the interface looks like a notebook, which is actually really great for being able to annotate and organize your code so that it's not just command line and difficult to understand for those folks who are not familiar with scripting or coding. And this can be packaged and published or shared out as well pretty easily. So in this instance, we are using pandas to do our analyses and data preparation here. So I'm basically pointing back to the data sets that I've already imported. So that's one of the benefits here in Watson Studio, that I don't have to re-import data. It's already in object storage as an asset. It's easy for me to call. And the first thing I'm doing here is creating a correlation matrix. I want to see what are some of the relationships between the variables in my sales data. So for example, the cost, the price, the volume, profit. What's the relationship statistically between those? So I get a nice correlation matrix output. I can also view this visually. So I've set up a heat map where I can see the strength of the correlation, which is in a darker color. So I can see there are some that are highly correlated, which I would expect in this instance. This is a fairly simple example, but you can imagine if you have a dozen or more variables, dozens of them, if you wanted to be able to quickly identify where there might be some strong relationships in your data, this is a good way to visually inspect and identify those. Importing the customer data and doing some descriptive analyses here. So for example, just doing a histogram to understand household income for my customers. Also using box plots, which are a nice visualization and not often available in some other out-of-the-box tools. So this is a good way for me to take a look, breaking down distributions of my categorical data against a continuous variable. So in this case, household income against some of those nominal or categorical variables like age and gender, geography, where customers are located. So it's a great way for me to be able to explore my data And obviously this is not an exhaustive example. There are lots of other exploratory analyses that we could do. So say I've done some initial exploration and I think, okay, I have a decent handle on the structure of the data. Now maybe I want to do some modeling. And I mentioned previously that Watson Studio is an interface designed for different user types. And I'm going to start with maybe the most novice. So we're going to look at auto AI experiments. And the beauty of this is that you basically just point back to the data set that you want to analyze. You select a target that you want to predict, and then you basically hit the run button, and it builds out a model for you. So in this case, I'm looking at, from my sales data set, the campaign response for a particular campaign that we launched. So I want to know what are the key drivers for why customers responded to this particular campaign. And if you look at the little progress map here for how Auto AI actually ingested, staged, modeled the data, you can see that it read the data set. It used best practices to retain a holdout data set, or it was doing training and testing partitioning here. Read in the training data, did some pre-processing, so probably dealt with some missing data, some data that needed to be binned or recoded. Then it did some model selection based on looking at the data and understanding what the target is and what the data characteristics looked like. And then it looks like it selected a random forest classifier model. And from there were 4 different kind of passes or pipelines to generate 4 different models. And for each one of these, there were different steps that were taken. So there was some parameter optimization that occurred, some additional feature engineering for one of the steps here. And if I scroll down, and you can kind of see here too, there's a star on one of the models, the pipeline 3. That's the model that was selected as the best model of the bunch here. And if I want to, I can click on this link to actually dig in to see. Now it does give us some statistics, the AUC, the area under the curve. And this is not the best model out there. This is using some sample data, but if you bear with me just to understand the capability. If we look at the output, we can actually see a rock curve, which is nice. We can also look at a confusion matrix to look at the breakdown or distribution of predicted versus actual, or observed versus predicted, which is always useful. We can also look at the model information. So some statistics on how many features were used, what was evaluated. And if I look a little bit deeper, it does tell me what was transformed. So there is a layer of transparency here in terms of the AI. So when it says feature generation, when it's doing transformations, you're getting that information back. It's not a total black box, which is nice. So I can see what has actually been prepared. I can also view feature importance. So what were the key drivers for this particular model? And it looks like the drivers for whether or not someone was responding to this particular campaign have to do with mostly demographics, household income, age. Some of the new features that were transformed are in there as well. Credit card information, whether or not they've responded to other campaigns. Those are all some of the drivers for our outcome here. So this is a good example of how you can do an automated model without having really any background in data analysis or statistics, but it gives you some level of insight into what might be driving your target outcome. But as I mentioned, the model statistics weren't fantastic, so this is the point that I would probably turn it over to a data scientist or a business analyst and ask them to dig in a little bit more to help me understand what's driving results to an outcome. So to do that, there are, again, a couple different ways we can we can approach a problem. But I want to show you first modeler flows. So for the folks who are familiar with SPSS Modeler, the technology has been embedded within Watson Studio. It's a new interface. And we've built out 3 different workflows here. And want to do some segmentation to understand our customers, want to do forecasting to project out profit, and then another to just build out a predictive model, which this particular flow could be, if I've asked someone after doing an auto AI model on that campaign, maybe I've gone back and asked my business analyst to actually build out a workflow now and dig in a little bit deeper, maybe tune some things on the modeling side to see if I can get a better result. But I want to show you maybe these 2 other examples. I'm going to open up forecasting, which I've run in the interest of time here. Essentially, I have my sales data that I've pulled in. I've done some data preparation because I'm doing forecasting, and this is time series forecasting. I've restructured my data so that I can run multiple models at the same time. I establish my time intervals, so how often or the periodicity I want my forecast to be generated. And then I'm actually building the model. And this guy right here, this orange square, is actually the model that's been generated. So I can view that model. And you can see I have a separate model by brand for my products. So those have all been generated simultaneously. I get information about what model was used. It looks like simple seasonal seem to fit the data the best, but there are several other methods that are typically used. I get my R-square information, so what proportion of the variance in the outcome can be explained by the inputs that we've selected, and then I get some error statistics as well here. And I also have a time plot that I've associated with the model, so if I wanted to visually inspect, it's great to look at the statistics, but what does that really mean? Let me open this up, and we can look at just a couple of plots. And I see, it does an okay job. Probably some tuning. I could probably go back in and do some additional tuning, but on the whole, it's not a bad forecast. The dots are the actual values for the branded profit. The line is the predicted value, and then that band around it is the confidence interval. So we'd expect most of our predictions to fall within that band. And for the most part, they do. We have a couple outliers that we need to pay attention to. So that's one example. If I go back to our main page here, we can look at a segmentation model. So, what are some of the key drivers that are separating out groups within our customer base or customer data set? So you can see right now in real time it's opening up the flow that I have already built. In this case, I have my customer data, which again already exists as a data asset, so it's very easy for me just to point back to customer data as a source. And I've associated a set of segmentation models with the data. If I view the model, you'll see that there were three models that were produced: a 2-step, which is an optimized Kmeans, a Kmeans, and then a Cahonin. And it looks like Kmeans has the best fit. This is based on silhouette, which is a measure of cohesion and separation. So basically that's saying, can we truly identify that there are distinct groups within the data set? I get some additional information about how large my clusters or my segments are. If I click on the highlighted model here, so I'll click on Kmeans, we can actually dig into the model itself to understand how it performed. And I did an okay job. If I look at the model information, it tells me in more detail for each cluster, the breakdown or distribution for each slice. I can look at the inputs that were driving that separation or the identification of the different groups. So again, some demographics, age, gender, income, credit card information, campaign response. Those are all driving the different segments. I look at, again, this is a visual representation of the distribution of the clusters or segments. And then I can look at some cluster comparison. If I actually click on the clusters, this is going to give me some additional information. So I can see there are some differences right off the bat in terms of the breakdown for each segment in my population here. So there are age differences, there are gender differences. There are also some differences in the proportion of folks who fall within a specific income category, and that's right here showing us the mode, so the most frequently occurring category. The primary credit card breakdown as well, and then the geographic indicator. There is some variety there in terms of where folks are located from a geographic standpoint. I can also look at distributions at an absolute level, or I can see it relative, in comparison to the whole population. So it gives me some good information about, what might be driving that I have, folks of a specific income bracket in a specific geographic region who are either male or female, of a specific age group. Those are the kind of key drivers or the breakdown for the segments that I'm seeing. That's one way to look at doing modeling using the visual interface. But we also do have the option to use RStudio. So there's a button up here that says Launch IDE using RStudio, and I've already launched it here. And so you'll see, if you're familiar with RStudio, it's a very familiar interface. Again, I've pointed back to my data set. This is my customer data. I have information about how many columns I've written, how many rows. And then the bottom left is my command line where I actually can execute code. There's an option here on the bottom right panel called Packages that actually gives you a list of packages that you can execute. But in this case, I've already basically pointed back to my data set. I've run some basic descriptives, and I've specified here that I also want to do a Kmeans, but I've specified my own parameters. So the difference here is from an analytics or data science standpoint, this particular interface is for folks who are familiar with doing coding, who might want control over how they're doing their analyses and how they want to set their parameters, if they want to write their own algorithms. So that's what I've done here with my Kmeans model, and then I've just done a simple plot so I can look at the breakdown of my different groups. And again, it's 5 groups. So that's the standard with the Kmeans, but I can actually see the breakdown of those 5 groups. So that is Watson Studio in a nutshell. I kind of walked through several different things, importing data, being able to explore data using notebooks, using the modeler flows to do some exploratory analyses, as well as a visual interface for doing modeling. And then finally looking at RStudio if you have folks who are inclined to be more code-based. And there are many more capabilities in this particular platform that I'd encourage you to try out. There's a free trial. It's easy. You can sign up and try it out yourself. So with that, I'm going to switch back over to our presentation and just wrap things up. So let me recap what we've covered. We started with an overview of data science and AI, Then we introduced IBM's Watson Studio, and we just walked through some of the platform's capabilities. At this point, you might be thinking, how do I get started with data science and AI? So the LPA recommended approach to getting started with data science and AI has 4 components. The first is to assess where your organization is in terms of data readiness. And we often use a maturity curve to help determine where an organization is in terms of the use of data and analytics, including culture, which is really important. Where are you currently, and are you trying to get to using data science and AI for business transformation? Next is a visioning exercise. What are the questions you would ask, or what are the business problems you would want to tackle that could increase revenue, decrease spend, improve customer satisfaction, help you compete and be a market leader, or transform your business? Based on the visioning exercise, we prioritize and identify a target use case to explore. Part of the target selection process is to determine what data you have available. You want to prioritize a use case that you have at least some data available. Something to keep in mind here, I often hear from clients that they don't feel like they can get started with data science because they're not sure if they have the right data. Data science is by nature exploratory. It's designed to help you do data exploration and to iterate quickly to determine if it will provide some insight. And if you do find that there are data gaps, that's actually okay. It can help you identify other areas or data that need to be collected to support advanced analytics efforts. Once you have a use case selected, the next step is to align your internal resources. The key players here are the folks who understand the business problem and who have access to your data. And finally, plan for a proof of technology, or a lot of times we call this developing a minimum viable product, using your data to address the selected use case. This is a great opportunity to see what's possible in a pretty low stakes way, and it often yields insight that can be used in a transformational way later. We would be very happy to help you at any point along your data science and AI journey. We can help facilitate a data science and AI vision workshop to help you identify the use case and data to develop an MVP. We can also support you as you undertake a proof point. And if you're not sure how to get started, we can help you to develop a strategy and roadmap that lays out a plan for aligning data science and AI within your business goals. Please do not hesitate to reach out and discuss how we can help you as you explore data science and AI. If you have any questions, please enter them into the chat window or email the address, this address, posted on the screen, and we will follow up with you. With that, I would like to thank you for your time and for tuning in today. All right, let's take a few questions. Let's see. What can you do with Jupyter besides data exploration? So good question. Jupyter Notebooks provide a Python scripting environment in a format that can be annotated and shared between team members. I showed some data exploration. You can do visualization. You can also do statistical modeling in the interface. You can also set up scripts for use in deployment. So you could actually set up a script, for example, to call your R code if you wanted to deploy that. So lots of different ways that Jupyter can be leveraged. Good question. Right, let's take another one. Is Watson Studio only on the cloud? So there are several ways that Watson Studio can be deployed. What I showed today was in the public cloud, but there is a desktop version that can be installed on an individual user's machine. So if you have folks in mind who you think specifically would want to use this, but you need to keep things locally, that's a good option. There's also something called Watson Studio Desktop, Watson Studio Local version that can be deployed on a hybrid cloud. So that could be behind your firewall or on a private cloud. So there are 3 versions: public cloud, desktop, or local. All right, let's do another question. Does Watson Studio integrate with other applications? Yes. there are several ways that you can integrate what you develop in Watson Studio with other applications. From a data source perspective, you can set up a data connection with a variety of systems or sources, including cloud object storage, which is what I was using. You could do streaming data if you have that. So if you are in e-commerce or insurance, oftentimes you have data streaming in, or if you're an entertainment provider, so streaming data is fine. Or you could also use on-premise data using a secure gateway. You can also build out data science models in Watson Studio and use the deployment functionality to set up web service calls to deliver scored results to an end application, or to make a round trip from the application. Other ways to integrate with applications, you can integrate data science results with other cloud APIs, and there are several just from IBM, let alone other providers. And for the folks on the line who use IBM Analytics technology, there is a tie between Watson Studio and Cognos Analytics. The newer releases of Cognos include Jupyter Notebooks in a limited capacity, and you can develop Python content in Watson Studio and publish it for Cognos to surface. So if you have data scientists who you want to actually build out the modeling content or additional visualizations of model output, you can have them do that in Watson Studio, and then that could be surfaced then in Cognos. All right, I'll take one more question. We haven't hired any data scientists yet. Can I still use this? All right, so this is actually a very common question that I get. The good news is that you don't need to have hired a team of data scientists to get started with Watson Studio. You saw in the demonstration that there's a visual modeling interface, and with some basic training, someone in your organization who knows the business problem and has an understanding of data can easily get started. The benefit there is that you can gain some initial insight, and when you do bring team members on board who have those coding skills, you already have a collaborative and governed environment ready to go. The other option is to start, if you want, with a visioning session, which we'd be happy to help facilitate, where you can identify where you want to use data science and AI, and determine what resources you might need to support those efforts. And of course, obviously, we'd be happy to chat with you more about this offline, including how we can assist you with that. Okay, well, thank you for the great questions. For anyone whose question I didn't get to, we'll follow up directly with you. If you think of anything later, please don't hesitate to reach out or visit lpa.com, and we will be in touch. Thank you again for joining us, and have a great day.